Hi, this is Ms. Fitzmaurice. This video is about graphing waves. So the two things that you should get from these videos are how to graph displacement time graphs and how to graph displacement graphs. And basically you should be able to tell me and be able to read off of a graph what information you can get from both of these graphs. So a displacement graph is basically like a snapshot of the wave that you see. Okay, so it might seem a little weird to have both of your axes being displacement, but if you think back to the Slinky lab, we have the Slinky right here, okay, and we have two dimensions. We have a right-left direction, and even though it's on the floor, let's say up-down direction. And so if we were to graph this wave right here, we have like, we could call this XY and XX, and we have a graph of our wave. It would basically be an outline of what our Slinky was doing. Okay, so think of a displacement graph as a snapshot of the wave. Okay, so a displacement time graph, on the other hand, has to track one part of the wave. So let's say we're tracking this coil of our Slinky right here and how it acts with time. So you could imagine that with time, this coil would move up to here and then back down to its original place. Okay, and so when we drew the graph, we would just have information about this coil. Okay, and if we said that up and down, this is the like y direction, then when we graphed it, when we graphed the wave, we're really only talking about this one coil, and we have a YT graph. Okay, and you can imagine this one starts out negative, and eventually goes positive and negative again. So what I want you to do is I want you to pause this video and I want you to go to page 12 of your Unit 7 packet. Okay, so on this page it says you have two situations, okay, and A is a photograph or a snapshot of a wave. And this, again, is kind of like a position displacement graph or a displacement graph. And B, you have an XT graph of your wave. And underneath, it asks you a bunch of questions. Okay, would you be able to find the wavelength with A only, with B only, or with both? Would you be able to find the period with A, with B, or with both, amplitude, etc. So I want you to take a couple minutes and I want you to try to decide and then check back for the answers. Alright, so now that you have paused this video and decided for yourself, let's start out with wavelength. So for wavelength, you need to know how long the whole wave is. So you can only do it with A, the snapshot. Okay. B will give you a sense of what this individual point is doing, but it won't tell you the distance between respective points. If you want to know the period, on the other hand, the snapshot doesn't tell you how fast the wave is moving. So if you want to know the period, you can only do that with B, an XT graph. Okay, so, and just to kind of give you a sense, your snapshot where you have YX, the wavelength will be this distance, okay, and for an XT graph, the period will look almost the same as the wavelength did. So the space between two waves, but in time. The frequency, since we know that frequency is 1 over f, or t equals 1 over f, that we can only find that when we can find t, and so only with B, the xt graph. The amplitude you should be able to find with both. Okay, so again, the amplitude is this distance right here, and it should be the same for the xt and the xy graph. The maximum speed and the speed of the wave for both of these, you actually need both graphs. Okay, you can't just have one, you need both, because v equals lambda f. So you're going to find lambda with your position graph, and you're going to find frequency with your xt graph.